Hi there. We need more circuit boards and, well, all of these things, so let's get to it. For the next factory, we're going to use this area around here. We got our iron, copper, and all the things here, so it will be fine. We have our deuterium, we got our iron and copper, and down here we have a couple of stations. One is to bring the silica in, another is to get the final product out. To make deuterium wire, we're gonna need deuterium ingots. And looking at all the recipes, I was considering making the pure deuterium ingot. The thing is water. This is kind of an issue. I've ran out of water around here. The closest one is actually near where we have the quartz mines, and that's a big pipe. Another option is the leach deuterium ingot. From what I can tell, this is one of the most efficient recipes we have. It gives us deuterium ingots at a rate from 3 to 2. Well, this is a 3 to 1, this is a 2 to 1. Actually, no, 3 to 2 is more efficient than 2 to 1, and that's another 2 to 1. But we're gonna need sulfuric acid, which we're not making. For sulfuric acid, we're gonna need water and sulfur, and there's a bunch of sulfur right here with a bit of water there. I'm gonna make the sulfuric acid here. We're gonna do another train station next to the silica load, and we're gonna ship it to this new train station I've built here. This is the sulfuric acid load train station, and this is the factory. Our sulfur is coming from all the way up there. It's gonna get balanced on this 3x3 balancer and shoved into the factories. The water is coming from down here. It's getting shoved into these pipes. I limited myself at 300 water per minute per pipe this time, and I'm dividing it around here, 6 machines per pipe. That's 300 water out of a 600 cubic meter per minute maximum. I hope this will be all right this time. As for the outputs, we got 3 outputs of 600 each, and the train station is all the way there. Give me a second. So instead of using that station, I dragged the rails all the way down here, and we're going to use this train station instead. That way we can get our 1800 worth of sulfuric acid right there and export it to wherever we need it to. Now all that's left is actually connecting this and see if it's all working. So far, so good. Everything seems to be working fine. I did build a few extra ones because later on we'll have better belts and we'll be able to get this one completely full up to 1200. But for now, yeah, this is working just fine. As an added feature, I had to add a few fluid buffers around here, as when it's loaded and unloading, this will prevent any issues. We got our sulfuric acid. Let's go and do some deuterium wire. We've built a few refineries to process all the raw deuterium into deuterium ingots, and did the same with the other 2 ores. We're putting together both iron and copper ore in these 2 sets of refineries, one for copper ingots and another one for iron ingots. We're going to use this side here now to process all these ingots into different parts. All the deuterium ingots and some of the copper ingots are going to be fed into this line of assemblers. This is going to be turned into quick wire, and we're good for deuterium wire for now. The output is going to be 4 different belts because this is a lot of quick wire. To be precise, we're producing 2,250 quick wire per minute. Due to the lack of water around these parts, we're just going to turn the ingots into sheets using constructors instead of refineries. We're going to get about 110 copper sheets out of this. Same for the iron ingots, just straight into constructors to do some steel pipes. Then we put the copper sheets together with the silica and we start doing some circuit boards at 50 per minute. After that, we get some quick wire, we get all the pipes and turn them into stators here. We then passed all that quick wire into a 3-to-2 balancer and took it to the 16 manufacturers. They're being fed our quick wires, our silica and circuit boards, and we're getting our high-speed connectors out of it. Just the manufacturers are like a quarter of this. Finally, we put our high-speed connectors together with the rotors and we get our electromagnetic control rods. In total, we're making about 100 per minute. And after a few tweaks and adjustments, we hit our target. I had to just, well, separate a few belts here and there. Our limit is 780 per belt. I just had one belt going through all of them, like the copper belt had to be separate in 3 different belts, and so on. Also, the silica was giving me a bit of an issue, so I had to get both belts from the train station into the storage container and then just one out of the storage container to actually make it right, because every time a train stops there, everything stops. So this guy just helps everything keep on going. Yes, everything is done. We got our 100 electromagnetic rods. Next, uranium fuel rods. We got everything except for this bit. Back where we're going to do the nuclear reactors, I've done 2 more stations, one for the electromagnetic rods and another one for the encased steel unload. Since we have done a bunch of sulfuric acid somewhere else, I'm also going to add one to it, and then all we need to do is concrete here. There's our sulfuric acid unload. Let's take care of the concrete now. We also got a belt of sulfur if we need more sulfuric acid, which I doubt will make it, but for now, I'm just going to grab this little stone belt and work on it. In order to use the whole miner we're producing for 180, we need 4 refineries, so there we are. At least I know for a fact we are using that whole node for concrete. Whether we're going to need 320 concrete per minute or not, I don't know, so I'll start the smart splitter overflowing to the storage container and some more for our pockets. We have everything that we need here, we just need to put it together. We're going to start with the encased uranium cells and take it from there. Since each blender will consume 50 per minute, we're going to be able to do 12 blenders, which will give us 300 encased uranium cells. As for concrete, we'll only need 180, we are doing more than enough. Ooh, shiny. I did forget the liquid output on these blenders. Let me take care of that. All the blenders put together, they will produce 120 sulfuric acid I'll need to dispose of. I'm going to feed it back into the system. That's 120 per minute. So besides setting up a valve up here, that's unlimited, well, 600, I set up another one from the trains that is set at 360. That way, our flow should be at 480, which is how much they will consume, and everything should just work, or at least I hope. I might need to flush this. Since each manufacturer will consume 20 per minute of encased uranium cells, we are producing 300, we're gonna need 15 manufacturers. Both the EM rods and the encased steel, they're gonna go downstairs and coming in through here and then up again into the manufacturers. Now, everything seems to be working. Let me see if I forgot something. Here's our very first uranium fuel rods. Seems like everything is working. Next, I believe, is just nuclear power plants. When it comes to the uranium fuel rods, I am producing 6 per minute. And each nuclear power plant, it's gonna burn it at 0.2 per minute. So each one could feed 2 technically, and we can feed 30 of them. But each one of these is very freaking expensive. We're talking about every modular frames, supercomputers, a bunch of aluminum. I might just overclock this. Save us on a lot of materials and we still get the same energy out nonetheless. Also nice because we can literally build 2. It's like 1 pipe per nuclear power plant. Instead of trying to drag pipes around, we just feed it directly from below. Yeah, I think that's a better idea. And I have no idea about the waste output, how much waste we're going to produce. I'm going to have to check it out afterwards, because it's not here neither. We will handle it, by the way. We're going to turn it probably into plutonium and get more power out of it. I'm going to grab one of these fuel rods and just give it a quick test. There it is. 0.5 per minute if we are overclocking it instead of 0.2. Oh, and there it is. 25 per minute. If each one will use 0.5 per minute, we can do 12 nuclear power plants, each one producing 60 to 50 megawatts. Yeah, that's going to be a bunch of energy. Well, I'm very, very excited about this. And we're also going to produce 300 toxic waste per minute. I think this is the design I want to go with, each one facing each other. We have set the splitters on one side, the mergers on the other, and then just set a few conveyor lifts to either load or unload things as needs be. I really wish I could do blueprints. This is way too big for the blueprint maker, so I'll have to do everything manually. And this is the result. After a long time, this wasn't the problem. That was a problem. My goodness, doing pipes is just horrible. But there we go. 60 water extractors, each 5 of them feeding one of those. It's done. Let's try and get this started, or so I would like to say. If we're going to produce toxic waste, I need to take care of it. At 300 per minute, before I know it, the whole thing is stopped again. For the uranium waste, we're going to use this alternate recipe. We're going to need 300 uranium and nitric acid. We don't have this at the moment, I believe. Not only we are already using the 600 per minute that we have available here, our train station is not coping with it. We are only making like 356 items per minute. We need a second train just to keep up with the 600 per minute. And while that train is going to get the next load, I'm going to prepare the next outpost of uranium. We got another train running. I expanded the train tracks all the way up there. We went something like this. This is the train actually on its way back. And we have to claim this node. We have our uranium. Now all we need is some nitric acid. And as long as I'm there, I might as well also get the aluminum casing. For the aluminum casing, I just slapped another train station here and we're good to go. Nitric acid is going to require nitrogen gas and iron, so another 2 stations and we're good. To process the 300 per minute of uranium waste, we're going to need 12 blenders, which means we need 180 nitric acid. Each blender produces 30, so we need 6 blenders. To make iron plates, which we need 60, we're just going to go with the normal one. All we'll need is 3 constructors to turn ingots to plates, and we'll need, since we have the sulfuric acid handy, we'll use this recipe, the leached iron ingot. We'll set the refinery for 90 per minute, and then feed it into 3 constructors to do our 60 iron plates. We've connected most of the pipes from down there, feed the water from the side, the plates from this way, and it seems we are getting a little dribble of nitric acid until things just buffer up. I haven't used the industrial fluid buffers, so here we go. Let's give this bad boy a chance. Chunky boy. We got all the parts. Let's do the 12 blenders now. Here's our 12 blenders. They're ready to process 1,200 per minute of non-fissile uranium and give us water. This is going to give us 480 water, so what I've done, split each 4 of them into one pipe, and we're sending it back for the water load train station. That way we can get rid of it on the steel area. It's not pretty, but oh well. When I finally kick things off, I'll have to come here, probably delete one of these water extractors, and life is good. Everything is connected. We just need the toxic waste to start coming in. But we still need one more step to turn this into something decent, which is the instant plutonium cell. And after that, into plutonium fuel rods. And I just remembered, I I still need to put the pressure conversion cubes into a train. Even if I overclocked and slooped the pressure conversion cubes that we have here, it wouldn't be enough. So we need to do this from scratch. We still got plenty of iron ore to go around here, and we can still overclock the miners if we need to. So let's steal some iron from here. We'll start by extending our foundries that we had up here and include 4 more of them. But instead of copper ingots, we're going to do iron ingots, and we'll bring up some plastic. We'll then send the iron into these 12 constructors to do screws. We'll put the rest of the iron ingots together with the plastic to get ourselves some iron plates using the coated iron plate recipe, and then we bring rubber up and feed it into these 6 assemblers that are doing reinforced iron plates using the adhered iron plate recipe. Then we'll get the screws and the reinforced plates into more assemblers to do modular frames. Yeah, I had to do a second floor, never mind that. I then had a few more foundries that I forgot about because we're going to need steel pipes. We need about 75 per minute, that's 300 ingots per minute extra that we needed. So we got our pipes, we got our encased pipes that are now coming from that train station over there. That train should be carrying it from that factory to this factory. Now we just need to put everything together, the frames, beams, pipes, and concrete that we've done around here. Yes, all very spaghetti, all very beautiful. Ah yes, all the spaghetti included. With that, we got our heavy modular frames. Overclocking it since we need 4 per minute. Then, after a little bit of overclocking, we got our 8 per minute. These 2 are doing 6 per minute, and this 2 is doing 2. For pressure conversion cubes, each assembler will consume 1 per minute. And so that means we need 8 assemblers, which means we need 16 radio control units. We only have like a couple of setups for radio control units, and if I follow the belt down here, I find these 2 manufacturers. They're doing 9 per minute. And I've checked the belt, and the only thing we're using this belt for is the other pressure conversion thingy-majiggy down there. And that's consuming 2 per minute, and technically, we don't need it anymore. We already achieved the 1000 nuclear passive thingy-majiggy, but I'm still earning points from that. Either way, if I come here and I sloop both of these, we'll start earning 9 per minute, that's 18. We're already feeding 2 to one of them, that leaves us with 16, which is exactly what we need. Technically, all I gotta do is steal from this. But bummer oh bummer, we can only build 7 assemblers here. So I'll just overclock this to 200% and call it a day. And after a little bit of belt chewy, we're getting these pressure conversion cubes, PCCs, from now on, happily going on the belts all the way to that train station. We're unloading the PCCs here, and I'm gonna try and build it all around here. Okay, this time, for real, we got everything. Each particle accelerator is going to consume 75 per minute. We're going to need 16 of these bad boys, so I need this times 4. Here is our 16 particle accelerators. I can't wait to actually see this thing starting to move. Now we need 16 assemblers to get things together. And there goes our PCCs into our 18 assemblers. I decided to do 18 instead of effing about with this. All I did is I did the last 4 at 50%. That should do it. I'm also cutting off the train stations, so I really hope I don't need any more train stations from here on out. And I'll probably need once we need to convert the waste from the plutonium into something else, I'm sure we're gonna need it. But that's a problem for future me. And finally, we're gonna sink the plutonium rods. We're gonna do 8 per minute. We can't really deal with the waste, so this is my only alternative of dealing with waste. Once we can do it, we can maybe get another, I don't know, 800,000 megawatts out of this. minus the power that we're going to use to deal with the waste. My only option, it will probably have to be like drag the train tracks all the way down here, get this belt to go underneath, and then get the train tracks to go back out like this. But again, that will be a problem for future me to deal with. For now, I'm going to turn on the nuclear plants and pray for the best. There they go, and there it comes. Jesus. Well, this is looking good. Our power skyrocketed, which is nice. And after much troubleshooting, I finally got this to work as intended. To start with, nitric acid. Don't use buffers on gases. It's not worth it. The way it works is that the volume of the gas that is in storage dictates the drain rate that you're going to get. It's okay when it's the fluid freight platforms here, but if it's a fluid buffer like those, yeah, it's not going to work. I had to do a second station, connect it directly, and now it's working perfectly. Because we didn't have nitric acid, well, the toxic waste started piling up on the nuclear power plants. They weren't doing too well. So in order to cope with it, I had to build a little storage container. And so far, so good. Not. Because I had too much toxic waste, I decided to just overclock this. Not taking into account the amount of non-fissile uranium that we're going to do. And in turn, we ended up with just a bunch of non-fissile uranium all over the place. As you can see, we have a bunch of encased plutonium now. Because on top of that, we were running out of aluminum. Go figure, after all of this. So we weren't getting enough pressure conversion cubes. It has been sorted in the meantime, and well, I just went back and slooped both the aluminum and then came back to the hub and also slooped the conversion, the PCCs. And well, we're now doing 12 per minute, well, train-wise. I believe we're doing like 18. We're doing 18. But because of the trains, they are a little bit slower. I really like how the nuclear power plants look like. They're so shiny, especially at night. It looks very cool. And seeing all of the accelerators work at the same time is also pretty darn cool. I have been putting something on the long finger for a long time because I didn't have the summer sloops for it. But here we are. We can just plant it right here. I've been using this on my exploration journeys. This gives you a flat out 500 megawatts when connected. So it's pretty handy for when you want to just get an hard drive or something. I haven't done it yet because each one of these requires 10 summer sloops, so I wasn't too eager to just use it for a little bit of power. But now that we are producing 100,000, it's actually worth the power boost. You know, it's another 11 gigawatts because of it. The capacity is pretty stable at the moment. The one thing that is unstable is our oil setup, but these guys, yeah, flat out all the time. It's a bit on the limit, the water, I must admit, but it's fine. I can always just turn it off, let it fill up, and it's good to go for another 10 hours. Anyway, the next episode will be all about completing the tiers, maybe even phase 5 if I have the time. For today, I hope you enjoyed, and I'll see you next time. Bye!